The UPSC CSE arena is an ever-evolving space where staying up to date becomes as crucial as maintaining a thorough preparation. With strategic planning and holistic coverage for exam syllabus, Vision IS Delhi presents GS Foundation course. Avail analysis and integration of current affairs with GS syllabus. All India test series with an innovative assessment system, inculcating post-test analysis, discussion, all India ranking, and more. Explore the holistic learning modules intrinsically designed for the ideal aspirant.
Hello, welcome everyone in the paper 2 discussion of physics conducted by UPSC this year examination 2024 mains. The same thing what we did in the previous class, that we'll have a very quick run through of out of 8 questions ideally which questions should have been selected. So if I directly go to look at the question number 2, these are very easy, very straightforward questions. तो ये तो हमारा 20 मार्क्स हमारा एकदम बिल्कुल दिख रहा है हमको कि 20 मार्क्स हमको आ रहे हैं. दिस इज इवन मोर इजी क्वेश्चन, तो 15 मार्क्स ये भी दिख रहा है. एंड देन द थर्ड क्वेश्चन इज अबाउट वन डायमेंशनल स्क्वायर वेल पोटेंशियल, ये भी हमारा हो गया. तो ये तो तय हमने कर लिया दैट वी आर गोइंग टू अटेम्प्ट क्वेश्चन नंबर 2. क्वेश्चन नंबर 3, दिस इज इजी, स्टोक्स लाइन. You need to explain Raman spectrum with help of classical theory and quantum theory. Lamb shift of hydrogen spectrum, second quantization. Now this was here which was unique. This part here, second quantization. If you do not know the meaning of the second quantization, then you may not get that 7 marks. ये 2 part का है, 8 plus 7. Second part के 7 marks हैं. तो ये पता होना चाहिए. But third is simple, EPR and NMR. This is a very standard question. ये सेम क्वेश्चन पेपर 1 में आया था, ये कभी नहीं हुआ होगा that एक ही क्वेश्चन पेपर 1 में और पेपर 2 दोनों में आया हो. This exact same question was asked by UPSC in paper 1 also in this year mains examination. I did discuss that just 2 days ago, right? This question is about drawing, plotting energy of harmonic oscillator and one-dimensional box. For me, this was an unusual question. In fact, I was not able to find the correct answer. I'm going to show you my calculation, but I was stuck in the calculation. So ideally, I would have avoided this question given that it is 15 marker question. So, except if I do not know about second quantization, but here there is a 15 marker question and I'm not very sure about this one, then I will choose question number 3. So I have decided question number 1, question number 2, question number 3, and then directly let's go to section B now. Does nuclear possess magnetic moment? Justify your answer. Define nuclear magneton, Bohr magneton, calculate their values. ये तो बहुत ही simple question है. अगले दोनों question बहुत simple है. और ये क्वेश्चन भी बहुत सिंपल है, तो हमारा फिक्स हो गया that we are going to attempt question number 2, question number 3 and question number 6 along with question number 1 and question number 5. राइट। हम न्यूक्लियर पार्टिकल फिजिक्स में हम होप करते हैं कि थोड़े आसान क्वेश्चन आए, और आसान इस बार आया भी था। बाकी जो क्वेश्चन है सॉलिड स्टेट फिजिक्स के हैं या इलेक्ट्रॉनिक्स का क्वेश्चन है, तो अगर आपको आता है तो ठीक है, नहीं आता है तो इसको लेके परेशान होने की जरूरत नहीं है। तो इस साल इस मामले में, इन दिस सेंस दैट you had this option to attempt questions and most of the questions you knew really well, so in this sense this was not a very difficult paper, right? कुछ part थोड़ा है जो जहां पे थोड़ा difficulty है, but more or less this was not a very difficult paper. Okay, so let's start our discussion with the compulsory question number 1. A particle limited to the x-axis as the wave function is given. Between only x is equal to 0 and x is equal to 2, wave function is given as bx square. It is 0 everywhere else. Find the probability that the particle can be found between x is equal to 0 and x is equal to 1.5. Find the expectation value of the particle position. अब यहाँ पे एक सबसे पहले क्लियर होना चाहिए कि हमको b कैलकुलेट करना पड़ेगा. This b needs to be calculated, and for that we will use the expectation value throughout space. It should be the probability of finding the particle with help of this wave function should be 1. But since this wave function only varies from 0 to 2, I can do a very simple mathematical manipulation, and then I can calculate the probability and I can calculate the expectation value. तो ये तो बहुत ही simple question है. Let's look at the solution. वेव फंक्शन क्या है हमारा, बी एक्स स्क्वायर है, बट वेव फंक्शन ओनली वेरीज बिटवीन 0 to 2. तो हम क्या कर सकते हैं, हम एक और ऐड कर सकते थे, हम वेव फंक्शन को प्लॉट कर सकते थे. यही होगा बी एक्स स्क्वायर फंक्शन, और ये हमारा x इज इक्वल टू 0 है, ये x इज इक्वल टू 2 है. एट x इज इक्वल टू 2 दिस बिकम्स 4b. ये मेरा phi x है और ये मेरा x है. एंड एट रेस्ट एवरी अदर प्लेस वेव फंक्शन इज 0. The first thing what I need to do here is that I need to normalize it. Normalize हम करेंगे psi x square और phi x square dx minus infinity to plus infinity. It should be 1. That probability, finding the total probability should be 1. Simple. But phi x is 0 everywhere else. It is bx square between 0 to 2. So the same integration transforms into this integration, b स्क्वायर x4 dx1. यहां से हमने b का वैल्यू निकाल लिया. b का वैल्यू जो है स्क्वायर रूट ऑफ बाई 5/32 है. ये हमारा b का वैल्यू है, दैट b इज स्क्वायर रूट 5/32. सो नाउ आई कैन राइट माई वेव फंक्शन phi x इज स्क्वायर रूट 5/32 x स्क्वायर. अब जो मेरा पहला पार्ट क्वेश्चन का क्या है, that probability between 1.5. probability क्या होता है, phi x square dx, x1 is 1, x2 is 1.5. हमने phi x निकाल रखा है, नॉर्मलाइज कर रखा है. this becomes 5/32, 1 to 1.5. do this, probability is 0.206. do this calculation, 5/32 x 5/5, 1 to 1.5. this becomes 0.206. this is my probability. And what is the expectation value? X psi x square dx. This is my expectation value. Remember, psi x में कोई imaginary part है नहीं, तो हमको bracket की जरूरत नहीं है. I can simply take psi x square without worrying about. अगर मान लो यही imaginary part होता हमारे wave function में, तो same expectation value हमको क्या करना पड़ता? We should have written that essentially now we are calculating, right? And then I needed to multiply psi star psi, and फिर हमको करना पड़ता है. यहाँ पे हमको कोई जरूरत नहीं है psi star x psi, simply because this is my wave function is not imaginary. वो कोई imaginary component है नहीं. So do this, and my expectation value comes out to be 5/3, 1.67. And by the way, that makes sense also, because think about it. When I plotted the wave function, and particularly if I plot x4, then look at this. The probability, this is let's say psi x square, and this is x, and ये सिर्फ 2 तक है, इसके beyond नहीं है. बट साई एक्स स्क्वायर का जो वैल्यू है, एज एक्स इंक्रीजेज इट इंक्रीजेज रैपिडली, so the expectation value should be closer to 2, and this is where it is 1.67, right? So it is basically 1.67, just somewhere here I have the expectation value, and that makes logical sense also. So I can be assured of the fact that I have done this calculation correctly. Okay, so let's go to the next question. What is the next question? Next question is that show that square of orbital angular momentum operator L square commutes with any of the components of angular momentum operator L. Is it possible to measure L square, Lx, Ly, Lz simultaneously? Give reasons for your answer. ये बहुत ही simple question है, right? If I have to show that it commutes, the angular momentum L square commutes with any of the component, let's choose that component as Lx. So L square is nothing but Lx square, Ly square, Lz square, Lx. Now I will use that जो हमारा overall commutator relationship है, that I can separate all of three of them separately. So Lx square Lx, Ly square Lx, Lz square Lx. बट हमने यहीं पे क्या किया कि हमने Ly स्क्वायर को Ly लिख लिया, और Lz को हमने Lz लिख लिया हमने यहीं पे. अब Lx स्क्वायर Lx तो 0 है, राइट? Lx स्क्वायर Lx माइनस Lx स्क्वायर, दैट इज 0. And now I am using this relationship, this commutator relationship, where I'm essentially using AB ABC, and I'm essentially using, so ABC plus ACB, that is the relationship I'm using. So I can take this Ly out, Ly Lx, Ly Lx Ly, Lz Lx, Lz Lx Lz, and now I'm going to use this relationship Lx Ly is IHS cross Lz, Ly Lz IHS cross Lx, Lz Lx IHS cross Ly, and when I put all of that, I find this 0. So L square Lx is 0. Whenever I have two operators commuting together, that Lx square Lx is 0, it means that they have same set of eigenstates. I can find same set of eigenstates for them, which means that they can be measured simultaneously. So L square can be measured with Lx, L square can be measured with Ly, L square can be measured with Lz. But can all of them be measured together? No. Why? Because as we already witnessed, that Lx Ly is not equal to 0, Ly Lz is not equal to 0, Lz Lx is not equal to 0, which means that they do not have common set of eigenstates, which means that they cannot be measured simultaneously. So I can only measure L square Lx, L square Ly, L square Lz. I cannot measure all of them together. That is going to be my answer. I need a laptop here. Just a second, I will take a break. Sorry, this arrangement was irritating me, so I had to change a little bit. My third question is, how is Rydberg constant related to emission wavelength of hydrogen spectrum? ये तो बहुत ही simple question है. हम यहाँ पे क्या कर सकते हैं? What is Rydberg constant? Rydberg constant directly related to emission wavelength of hydrogen spectrum through the Rydberg formula. What is Rydberg formula? 1 by lambda RH 1 by n1 square n2 square. RH here is Rydberg constant, and lambda is the wavelength which will be emitted when the transition happens from n2 to n1. Very simple. ये बहुत ही simple question है. अब यहाँ पे अगर आपको कुछ और लिखना था, तो what you could have done, you could have derived Rydberg constant using Bohr's theory. अगर आपको थोड़ा और इसमें एडिशन करना है, then you could have derived the value of Rydberg constant using Bohr's quantization of hydrogen atom. That can fetch you some extra marks. I have not done it here. That is a very standard thing which you study even in your like class 11th, 12th days. And you definitely have studied when you learned atomic and molecular physics. So यहाँ पे one more thing which you could have done here is that use the quantization, assuming hydrogen atom, use the Bohr's theory and derive the value of Rydberg constant, and you can write down that this value matches with experimental value which we calculate. And we can talk about that Lyman series के लिए N1 will be 1, N2 2 3 4. Balmer series के लिए N1 will be 2, N2 3 4 5 up to infinity. So this is what Rydberg constant is all about. So this was a very, very easy question. Okay, now this is a very interesting question. Find the energy of the particle of mass m moving in a potential field which is given, for which the time independent wave function that is given where b is constant. अब इसको solve करने का दो तरीका है. एक तो तरीका ये है that आप इसको directly इस wave function को Schrödinger equation में fit कर दो. Write down the Schrödinger equation, minus h cross by 2m d2 psi by dx2 plus v psi is equal to e psi. But I have not adopted that approach. What I have adopted is that I know, looking at the function Vx is equal to 2h square b square x square by m, I know that this is harmonic oscillator, half m omega square x square. So I can calculate the value of omega. And by looking at this function, I know that this is nothing but ground state. ये हमारा ground state है और हमारा जो harmonic oscillator है वो ground state में है. And what is the energy in the ground state? H cross omega by 2. But यहाँ पे हमको सब कुछ दे रखा है. The only thing which we do not know is B here. That B is unknown to me. So I need to calculate the value of B. तो दो तरीका इसको solve करने का. Sorry, did I miss some question? अच्छा नहीं, बीच का एक क्वेश्चन रह गया हमारा. सॉरी, अब चलो एक बार इसको 1e को डिस्कस कर ही लेते हैं. नाउ दैट वी आर डिस्कसिंग इट, पहले हम 5th क्वेश्चन डिस्कस कर लेते हैं. Vx is 2h cross square b square x square by m. Psi x is e raised to the power minus bx square. We can write this. This is a quantum harmonic oscillator problem in ground state. For quantum harmonic oscillator, what is my potential energy? Half m omega square x square. And this half m omega square x square is nothing but 2h cross square b square x square by m. तो वहां से हमारा ओमेगा निकल के आ गया. ओमेगा is 2h cross b by m, right? And I then know that what is the energy of harmonic oscillator? Energy of harmonic oscillator is n plus half h cross omega. For ground state, I know that the wave function is in ground state. N is equal to 0, E naught is h cross by omega 2. मेरा आंसर आ गया h cross square b by m. But अगर हम यहाँ पर छोड़ दे तो हमको थोड़ा नंबर कम मिलेगा. Because I know that wave function is given in b, but I can use the normalization condition and I can find out b. So normalization condition हम क्या करेंगे? Psi x square dx minus infinity to plus infinity 1. E raised to the power minus 2bx square dx is 1. अब remember this formula, e raised to the power minus alpha x square dx. When I integrate over space minus infinity to plus infinity, it is nothing but square root of pi by alpha. यहाँ पे जो alpha है वो 2b है. So this becomes pi by 2b1. b हमारा आ गया. What is b? Pi by 2. तो b हमारा निकल के आ गया pi by 2. Use the value of b here. h cross square by m pi by 2. We have this answer pi h cross square by 2m. ये हमारा एनर्जी निकल के आ गया. Ideally you should have found this answer, not left it here. तो एक तो तरीका ये है, and जो दूसरा तरीका है, which I have written it here as alternative solution, that I know the Schrödinger equation minus h cross by 2m d2 psi by dx2 plus v psi is equal to e psi. v दे रखा है, psi दे रखा है. This is one equation and there is one unknown, and what is that unknown? E. So v is known, psi is known, calculate E. So psi यहाँ पे fit करो, d2 से by dx2 निकालो, यहां पे लिखो, आपका E निकल के आ जाएगा, बट वहां पे भी आपको B कैलकुलेट करना पड़ेगा. इवन देन यू हैव टू कैलकुलेट B यूजिंग नॉर्मलाइजेशन कंडीशन. तो इसको सॉल्व करने का दो तरीका था. आई अडॉप्टेड द फर्स्ट मेथड सिंपली बिकॉज इट वॉज सिंपलर टू डू. Did not involve lot of differentiation. Okay, now let's come to the question which I missed. Fourth question, compulsory का जो fourth question है, explain how the hydrogen spectrum is used for imaging the universe. Right, this is a fantastic question. बड़ा ही standard सा question है वैसे, बहुत बार यूपीएससी ने पूछ रखा है. तो पहले तो हाइड्रोजन स्पेक्ट्रम यूनिवर्स के लिए जो हम यूज करते हैं बहुत क्लियर होना चाहिए दैट वी आर नॉट टॉकिंग अबाउट टिपिकल हाइड्रोजन स्पेक्ट्रम which we have studied in Bohr's theory of hydrogen. We are not talking about that. We are essentially talking about this particular spectrum which is called 21 centimeter line, which plays a crucial role in astronomy and imaging the universe. But a 21 centimeter line आता कहाँ से ये पता होना चाहिए. 21 centimeter line is a result of what we call hyperfine splitting. What is hyperfine splitting? Hyperfine splitting is a result of interaction between angular momentum of electron and nucleus. And hydrogen atom में nucleus में क्या है? बस एक proton है. So this spin angular momentum of electron and spin angular momentum of electron and proton lead to this two possible value s is equal to 0 and 1. And this leads to two states, s is equal to 1, s is equal to 0. And the energy difference is 1420 megahertz. ये आपको याद रखना चाहिए. And 1421 megahertz, the corresponding value here is 21 centimeter. But ये जो पूरा ट्रांजिशन है वो बहुत अनलाइकली है. आपको ये लिखना पड़ेगा कि ये फॉरबिडन ट्रांजिशन है. डेल्टा एस इज इक्वल टू 0 रूल को वायलेट करता है. s is equal to 1/2, s is equal to 1/2. So delta s is equal to 0 रूल को वायलेट करता है. एंड इस ट्रांजिशन होने का जो प्रोबेबिलिटी है बहुत कम है. एंड प्रोबेबिलिटी जितना कम होगा ट्रांजिशन का हाफ लाइफ उतना ज्यादा होगा. सो दिस ट्रांजिशन हैज अ हाफ लाइफ ऑफ 10 to the power 7 years, which means that on earth in lab we will not witness this, right? नॉर्मल जो भी हमने हाइड्रोजन स्पेक्ट्रम पढ़ रखा है हमको दिखेगा, पर 21 सेंटीमीटर लाइन हमको अर्थ पे नहीं दिखेगा. कहां दिखेगा हमको? यूनिवर्स में. बिकॉज रिमेंबर all of the matter which we see, more than 70% of the matter is hydrogen. Hydrogen is the simplest element made of just one proton and one electron. So hydrogen is everywhere in this universe. No matter in which line of direction you see, you have hydrogen. And there is so much of hydrogen that despite such low probability, I should be able to find 21 centimeter line from each direction, which will tell me the prevalence of hydrogen in the universe. And which will essentially tell me about stars and galaxies. But ये जो 21 centimeter line है, as we know that this is 14, what was the exact value? 1420 megahertz. So I know that the frequency should be 1420 megahertz, but if galaxies are moving far away from us, they will be Doppler shifted. So we will not measure 1420 megahertz. That will also allow us to understand about relative motion of galaxies with respect to each other. And this is what I have written here. So directly अगर हम application पे jump करें, then I will not get extra marks. I will get out of 10 2-3 नंबर मिल जाएगा अगर हम डायरेक्टली एप्लीकेशन पे जंप करें. हमको पहले एक बैकग्राउंड देना पड़ेगा दैट कौन से हाइड्रोजन स्पेक्ट्रम की बात हो रही है. वी आर टॉकिंग अबाउट हाइपरफाइन स्प्लिटिंग वेयर the spin angular momentum of electron and proton give rise to two energy states, and that leads to a transition which is highly unlikely. Hence you cannot witness it on earth, but you do witness this in the universe because universe is filled with hydrogen. So now we can write that this has application in radio astronomy. Assuming uniform distribution of hydrogen atoms, each line of sight reveals a hydrogen line, the difference being Doppler shift. And using Doppler shift, we can know the galaxies, distance among others within the galaxy can be calculated. That is the first thing. And in cosmology also, by mapping the red shift of 21 centimeter line, we can know about the initial stages of universe, particularly the reionization stages of universe. So that is how hydrogen spectrum, this hyperfine splitting of 21 centimeter line is used in imaging the universe. तो ये हमको लिखना पड़ेगा पूरे बैकग्राउंड के साथ, only then you are going to get marks. So let's come to the question number 2 now. Question number 2 का जो first question है उसमें 4 सब पार्ट हैं, all 4 of them are related. L square Lz is 0, Lz L plus L minus Lx Ly. ये बहुत ही सिंपल है, चारों 5-5 नंबर के क्वेश्चन है, थर्ड फोर्थ तो साथ में ही हो जाएगा. L square Lz तो अभी हमने प्रूफ करके दिखाया ही. देखो सेम क्वेश्चन को यूपीएससी ने एक ही पेपर में रिपीट किया है, मतलब इससे बढ़िया और क्या ही हो सकता है. देयर कैन बी नथिंग बेटर देन दिस. सी दिस, यू हैव योर आंसर, यू ऑलरेडी हैव डन दिस. Okay, but L plus, what is L plus? L plus is called ladder up operator. It is a raising up operator. When it operates on a state Lm, it makes this Lm plus 1. Hence we call it ladder up operator. And L plus is nothing but Lx plus I Ly. So I need to find the commutator of Lz and L plus. So Lz, L plus को substitute करो, Lx plus I Ly, separate करो, this becomes Lz Lx plus I Lz Ly. This becomes I h cross Ly plus I Lz Ly is minus I h cross Lx, which becomes Lx itself minus I square is plus 1. So Lx plus I h cross Ly, and that was nothing but L plus. So my commutator relationship Lz L plus is h cross L plus. ये बहुत ही सिंपल है. अब L minus जो है lowering operator है. It is a lowering operator. When it operates on a state Lm, it makes this Lm minus 1. And L plus is Lx plus I Ly. L minus is Lx minus I Ly. अब हमको इस क्वेश्चन में क्या निकालना है? We have to calculate L plus L minus का commutator. So L plus L minus is nothing but L plus L minus minus L minus L plus. अब पहले L minus L plus calculate कर लो. कैलकुलेट करके आपको आएगा that this is Ls square minus Lz square minus h cross Lz. And similarly आप L plus L minus कैलकुलेट करके देख लो. This will come out to be Ls square minus Lz square plus h cross Lz. दोनों को subtract करो, your answer is 2h cross Lz. And we already have obtained that L plus L minus is Ls square minus Lz square plus h cross Lz. So this was perhaps the simplest question. मतलब ऐसे होता है ना कि यूपीएससी ने आपको बस रख के दे दिया, खुश हो जाओ आप 20 मार्क्स ले लो. 4 पार्ट है, 5-5 पार्ट का, हार्डली लगेगा आपको 3-4 मिनट में पूरा आंसर 5 मिनट में खत्म हो जाएगा, एंड 20 नंबर हो गया आपका. Okay, by the way, there is a misprint in this question. ये जो यहां पे इन्होंने L plus Ly लिख रखा है इज इक्वल टू Ls स्क्वायर माइनस Lz स्क्वायर प्लस h क्रॉस Lz, ये Ly नहीं होगा, ये L plus L माइनस होगा. ये मिसप्रिंट है यहां पे, राइट? तो आई हैव, एंड दैट इज व्हाई आई मेंशन दिस. ये L plus L माइनस विल बी this value. So this is a misprint in the question, and that misprint is also in, by the way, Hindi print. So I have mentioned it here in the solution that in question there is a misprint L plus Ly, it should be L plus L minus, तब जाके हमारा आंसर ये ठीक होगा. To be और सिंपल है, ग्राउंड स्टेट ऑफ वेव फंक्शन दे रखा है, निकालना भी नहीं है आपको, दे रखा है, एंड ये 15 मार्क्स का क्वेश्चन है. एट विच पॉइंट इज द प्रोबेबिलिटी डेंसिटी मैक्सिमम? व्हाट इज द वैल्यू ऑफ मैक्सिमम प्रोबेबिलिटी डेंसिटी? तो दिस इज अ वेरी वेरी सिंपल क्वेश्चन. साइन नॉट एक्स इज गिवन, प्रोबेबिलिटी डेंसिटी क्या होता है? इसी वेव फंक्शन का स्क्वायर ले लो आप. सो एम ओमेगा बाई पाई एच स्क्वायर 1/2 ई माइनस एम ओमेगा एच क्रॉस एक्स स्क्वायर बाई एच क्रॉस. हमको मैक्सिमम निकालना है, Maximum कब होगा? When dp by dx is equal to 0 and d2 by dx2 at that point is less than 0. That will be the maximum point. Take the differentiation d by dx. Do this differentiation. This is my value, minus 2m omega x by h cross e raised to the power minus m omega by h cross x square. This cannot be 0 unless x is infinite. But हम infinite values तो हम लेंगे नहीं, तो इसका मतलब क्या है कि ये 0 है, और ये 0 का मतलब क्या है? x 0 है. So where is the probability density maximum? At x is equal to 0. And that makes sense also. Because of function को plot करके देख लो. ये फंक्शन को आप प्लॉट करोगे कैसा दिखेगा? ऐसा दिखेगा. मैक्सिमम कहां पे है? x इज इक्वल टू 0 पे. तो प्लॉट से भी आपको दिख रहा है दैट वेयर इज द प्रोबेबिलिटी मैक्सिमम? इट इज मैक्सिमम एट x इज इक्वल टू 0. इट इज अ गॉसियन फंक्शन, सिमेट्रिक टू द बोथ साइड, एंड एट x इज इक्वल टू 0 इट इज मैक्सिमम. दे रखा है मैंने प्लॉट यहां पे बना के. दिस इज द प्लॉट, साई एक्स स्क्वायर वर्सेस x. एंड x 0 है तो p क्या हो जाएगा? e raised to the power 0, that is 1, but this will be left, m omega by pi h cross 1 by 2. So this is the probability, maximum probability, which is occurring at x is equal to 0. 15 marker question, again should not take more than 5 minutes to solve this question. The next question is little bit tricky. ये दोनों क्वेश्चन इंडिपेंडेंट नहीं है, ये दोनों क्वेश्चन एक दूसरे पे बहुत ज्यादा डिपेंडेंट हैं. Assuming the potential seen by a neutron in a nucleus to be schematically represented by one-dimensional infinite rigid wall potential of length 1 femtometer, estimate the minimum kinetic energy of electron. आपको इलेक्ट्रॉन का kinetic energy निकालना in such type of setup. Then in the next question you have to estimate the energy of neutron bound within nucleus as described above. तो पहले आप इलेक्ट्रॉन निकालोगे, फिर न्यूट्रॉन निकालोगे, and then you have to answer can an electron be confined in nucleus, explain. तो ये जो दोनों क्वेश्चन हैं ये बहुत ज्यादा कनेक्टेड हैं एक दूसरे से, ये एक दूसरे से इंडिपेंडेंट क्वेश्चन नहीं है. तो लेट्स सॉल्व दिस. हमने न्यूक्लियस को इनफाइनाइट स्क्वायर वेल पोटेंशियल मान लिया है. इनफाइनाइट स्क्वायर वेल पोटेंशियल का सॉल्यूशन हमको पता है, साई एन एक्स 2 बाई एल साइन एन पाई एक्स बाई एल. एंड एनर्जी क्या होता है? एन स्क्वायर एच क्रॉस स्क्वायर पाई स्क्वायर 2m एल स्क्वायर, वेयर एल इज द लेंथ ऑफ द पोटेंशियल वेल. मिनिमम एनर्जी के लिए n क्या होना चाहिए? 1 होना चाहिए, विच मीन्स that energy, minimum energy will be pi square h cross square by 2m l square. अब ऐसे वेल में अगर हम इलेक्ट्रॉन हो तो इलेक्ट्रॉन का एनर्जी क्या होगा? m फॉर m, इलेक्ट्रॉन का मास इज 9.1 मल्टीप्लाइड बाई 10 to the power minus 31. कैलकुलेट करो, द एनर्जी विल बी 376.1 गीगा इलेक्ट्रॉन वोल्ट. दिस शुड बी द एनर्जी ऑफ इलेक्ट्रॉन if it is confined within nucleus. But now compare the same thing for neutron. Neutron का मास क्या है? 1.67 multiplied by 10 to the power minus 27. You calculate the same value in electron volt, and this is about 200 mega electron volt. Now we know this. So neutron actually does exist inside nucleus, and we know this. अब हम लॉजिक अपना हम सिंपल लॉजिक अप्लाई करेंगे. that for electron to be confined in a nucleus, the minimum energy required as calculated is about 376 GeV. Of course, I have assumed it to be square well potential, infinite square well potential. The typical binding energy within a nucleus is in the range of MeV, right? As shown in the next problem, where minimum energy is about 203 MeV. तो minimum energy जो है MeV के रेंज में है, मेगा इलेक्ट्रॉन वोल्ट के रेंज में. इलेक्ट्रॉन को कितना एनर्जी चाहिए होगा? गीगा इलेक्ट्रॉन वोल्ट के रेंज में चाहिए होगा, which immediately tells you that electron cannot reside within a nucleus. And by the way, the same thing can also be explained using principle of uncertainty, that if delta x is very small, delta p must be very large. This corresponds to very high kinetic energy for electron, which is not feasible inside nucleus. तो सेम चीज को जो हमने स्क्वायर वेल पोटेंशियल से एक्सप्लेन किया है, आई कुड ऑल्सो हैव एक्सप्लेन द सेम थिंग यूजिंग प्रिंसिपल ऑफ अनसर्टेनिटी. Those who wrote this in the answer, they will definitely get 0.5 marks extra. So this was a question where these two questions were not independent of each other. They were very much dependent upon each other. चलो next question देखते हैं. How do Stokes line appear in Raman spectrum as per classical and quantum theory of Raman effect? 20 marks का question है, ठीक है. तो हमको रमन इफेक्ट एंड स्पेशली फॉर स्टोक्स लाइन आपको क्लासिकल थ्योरी से एक्सप्लेन करना है और आपको क्वांटम थ्योरी से एक्सप्लेन करना है, बट पहले आपको बताना है कि होता क्या है. हम क्या करेंगे? हम बोलेंगे that when molecule in some state is irradiated with suitable frequency, there are three possibilities. The first possibility is that after interaction with the molecule, जो scattered light है, उसका frequency same रह जाए. This was done by Rayleigh 100 years before Raman. So this part we already knew that this is called Rayleigh scattering, where the scattered and absorbed frequency they are same. But what Raman showed, that there are other two possibilities, that the scattered frequency can be more, the scattered frequency can be less. This higher frequency scattered is called anti-Stokes line, and the lower frequency scattered is called Stokes line. This is what it will look like on a spectroscopy. This line here is elastic scattering, but these two lines, which are Stokes line and anti-Stokes line, they represent Raman lines. Okay? So this happens. We know that this happens. How can we explain this? We can explain this first with help of classical theory. Classical theory में हम क्या करेंगे? And by the way, Raman spectroscopy is shown by almost everything, almost every molecule. हम इसमें क्या करेंगे? In presence of dielectric field, molecules get polarized. We will use the concept of electrodynamics, which we have studied in our classical physics. We know that dipole moment becomes proportional to the electric field, and this electric field is essentially associated with this incident light. जो light है, that is electromagnetic wave. So this E here is due to incident light, and which means that this polarizability, this means if I take E is equal to E naught sine 2 pi nu t, nu is the frequency of light, then I can write this dipole moment as alpha E naught sine 2 pi nu t. But here is the thing, even this polarizability alpha is not constant. This polarizability changes due to internal motion, such as rotation or vibration. If molecules start vibrating and rotating, then this polarizability alpha, which we have assumed it to be constant, will not remain constant. That will also change periodically. It will change very little bit, but it is going to change. So if I assume that this alpha is some sort of periodic function, alpha naught plus beta sine 2 pi nu naught nu dash t, where alpha naught and beta are constant, and then when I write polarization alpha E, so now alpha E becomes alpha naught plus beta sine 2 pi nu dash t. What is this nu dash? This is the frequency of vibration of polarizability. And then what is nu here? This is nu the frequency of the incident electromagnetic wave. do a simple trigonometric manipulation and you find that polarizability is alpha naught E naught sine 2 pi nu t cos 2 pi nu minus nu dash t cos 2 pi nu plus nu dash t. So I find all these terms. Oscillating dipole, this becomes an oscillating dipole which has frequency nu plus minus nu dash as well as nu, and this plus minus nu dash accounts for Raman spectroscopy, Raman scattering, and that nu and nu dash, that nu remain unchanged, that accounts for Rayleigh scattering. Seems logical, but there is a problem. In this theory, there are two problems. The first problem is that as per this theory, the intensity of Stokes and anti-Stokes line should be same. That Stokes line और anti-Stokes line का जो intensity है, वो same रहना चाहिए. लिखा है हमने. Classical theory has limitations. हमको दिखता क्या है? Classical theory के हिसाब से क्या होना चाहिए? That at room temperature, both Stokes and anti-Stokes lines can have same intensity. But in reality, that does not happen. Stokes line at room temperature are much more brighter compared to anti-Stokes line. And as temperature increases, anti-Stokes line का जो probability है, वो होने का chance ज़्यादा है. And second, in this theory, there is no limitation on what type of frequency can be used. It essentially is saying that no matter what the frequency is, we are going to have Raman spectra, which of course does not happen. That any value of rotational Raman spectra is possible, which is actually not observed. We find a quantization, we find specific values. And this is where quantum theory comes into place. Because in quantum theory, what do we assume? I assume two energy states, n0, n1, separated by some energy delta E. As we know from Boltzmann distribution, that more number of molecules will be in lower energy state compared to higher energy state. So if a light of some frequency nu falls here, some molecules will go to a higher energy state. तो हमने लिखा है इसको, when molecules are in low energy state, E double dash, and again delta E from photon goes to an excited state, which means that the scattered photon now has less energy, and if it has less energy, it also has less frequency. So we can now use a simple conservation of energy. This is the incident energy, h nu I. Molecules were in a lower energy state, represented here by nu double dash. That nu s is scattered frequency. E nu dash representing higher energy of molecule. So nu s is nothing but nu I minus E nu dash minus E nu double dash divided by h, nu I minus nu s. ये Stokes line है. हमको Stokes line explain करना है. ये Stokes line है. तो अब जो है दो चीजें explain कर रहा है. We know that at room temperature, हमने लिखा है, at room temperature there are more molecules in lower energy state. Hence at room temperature Stokes line is intense. But with increasing temperature, population at higher level increases with more probability of anti-Stokes line. So this quantum theory is now able to explain the intensity variation between Stokes and anti-Stokes line. First. And second, Stokes shift is not random, it is quantized. This quantum theory overcomes the limitation of classical theory. ये हम जब complete करेंगे हमारा answer complete होगा. So this much you needed to write. First you needed to explain with classical theory, you needed to talk about its limitation, and then you had to talk about the quantum theory of Raman spectroscopy. Third B क्या है देखो. There are many questions on spectroscopy this year. What is Lamb shift in the fine structure of hydrogen spectrum? Discuss its theory based upon second quantization. तो first तो हम सबने पढ़ रखा है, but जो second है, second quantization, ये something which you should, if you do not know, then इसके फिर मार्क्स नहीं मिलेंगे. सेकेंड क्वांटाइजेशन का मतलब होता है दैट इट्स नॉट एनर्जी ऑफ पार्टिकल्स बीइंग क्वांटाइज्ड. Second quantization arises in quantum field theory. In quantum field theory, it is field which is quantized. So even electromagnetic field is quantized. It cannot take any value. The field in itself is quantized. That is called second quantization. Anyways, first let's talk about what is Lamb shift. When we did fine structure of hydrogen atom, we used Paul Dirac's perturbation theory. Dirac made two corrections in hydrogen spectrum. जो Bohr का theory है, that was not able to explain fine structure. So Dirac made two corrections. The first correction Dirac made was relativistic correction, and the second correction he made was spin-orbit interaction. And using relativistic correction and spin-orbit interaction, he gave us fine structure of hydrogen atom. But in Paul Dirac theory, the two states, 2s1 by 2 and 2p1 by 2 should have the same energy. But when we do the fine structure of hydrogen atom, we find that there is a little gap between these two states, which cannot be explained by Dirac's theory. And this is where Lamb shift comes into play. So this is what I have explained. Lamb shift is a small difference in energy between two energy levels of the hydrogen atom that cannot be explained by Dirac's theory. ठीक है? Dirac ने क्या किया था? Dirac के हिसाब से जो fine structure है, that arises from relativistic correction, which is true. Spin-orbit interaction, that is also true. And as per Dirac theory, these two states, ये लिखना जरूरी है. ये आपको specifically mention करना पड़ेगा that these two states, 2p1 by 2, 2s1 by 2, same L and S value, should have the same energy, should be identical. But then we find, when we do experiments, we find that there is a difference between these two states. This difference is not very large, but there is a difference. That difference is of about 1058 megahertz. And because of that, जो आपका actual fine structure है, जैसे मान लो this is n is equal to 3 state, let's take Balmer series, n is equal to 3 state, n is equal to 2 state, then you find that this 2s1 by 2 and 2p1 by 2 are not same. They transition, and then because of that, you will find some extra lines which cannot be explained by Paul Dirac's theory. So this is called Lamb shift. And Lamb shift occurs because of quantum electrodynamics. It is verification of quantum electrodynamics. तो ये अब हम यूज करेंगे. सेकेंड पार्ट जो क्वेश्चन के है, सेकेंड क्वांटाइजेशन. व्हाट इज सेकेंड क्वांटाइजेशन? इन क्वांटम, जो देखो यूनिवर्स को एक्सप्लेन करने का जो सबसे बढ़िया थ्योरी है हमारे पास, वो है क्वांटम फील्ड थ्योरी. इन क्वांटम फील्ड थ्योरी वी टॉक अबाउट वेरियस क्वांटम फील्ड्स, and as those fields excite, and those fields are quantized by the way, first thing, and as they get excited, they release particles. And so it is actually field which is much more realistic description of universe as we know, rather than the particles we think. So what is second quantization? A formalism in quantum field theory where fields rather than particles are quantized. This is the most important part. For example, electromagnetic field is a quantum field. Remember जब हम electrostatics पढ़ते हैं, electrodynamics हम पढ़ते हैं, तो वहाँ पे हमने electric field, magnetic field को हमने quantization कभी नहीं पढ़ा है हमने. We always thought of them as a continuous field. They can take all the possible values. But what this formalism tells you, that electromagnetic field is a quantum field, and this allows us to now calculate the effects of, ये दो वर्ड्स आपको मेंशन करना पड़ेगा, वैक्यूम फ्लक्चुएशंस एंड सेल्फ एनर्जी करेक्शंस. एंड सच टाइप ऑफ क्वांटम फील्ड थ्योरी इन दिस केस इज कॉल्ड क्वांटम इलेक्ट्रोडायनेमिक्स. एंड ये जो लैम्ब शिफ्ट है, दैट अकर्स बिकॉज ऑफ दिस क्वांटम इलेक्ट्रोडायनेमिक्स, दैट इट इज explained now as a result of the interaction between electromagnetic fields, vacuum fluctuation. And that electromagnetic vacuum fluctuation essentially changes the energy state of 2s1 by 2, 2p1 by 2, and we find this fine structure. So this causes a modification of electron self energy leading to shift in energy levels, and that shift is very much visible in case of 2p1 by 2 and 2s1 by 2. तो ये दो वर्ड आपको लिखना पड़ेगा, सेल्फ एनर्जी करेक्शन, interaction between electrons and the electromagnetic field, vacuum fluctuation and self energy correction. ये दो चीजें लिखनी पड़ेंगी, and they both occur as a result of this formalism in quantum mechanics, that it is electromagnetic field which is quantized. And by the way, it is not just electromagnetic field. All quantum fields such as Higgs field or other fields, all of these fields are quantized. The next question is about describe electron paramagnetic resonance, highlights its differences with NMR, discuss its application. देखो बहुत सारे पार्ट हैं, 3 पार्ट हैं. पहले EPR डिस्क्राइब करना है, NMR से हाईलाइट करना है. NMR के बारे में बहुत डिटेल में नहीं जानना है, बस हाईलाइट द डिफरेंसेस एंड डिस्कस इट्स एप्लीकेशन. तो आप NMR का बहुत डिटेल में थ्योरी देना शुरू कर दोगे तो कोई काम का नहीं है. यहाँ पे 15 नंबर का क्वेश्चन है, 3 पार्ट है. थिंक ऑफ ऑल 3 पार्ट्स एज ऑफ 5 मार्क्स. So what is electron paramagnetic resonance, which is also called electron spin resonance? Same thing. I could have used EPR or ESR. They are the same thing. This is a spectroscopic technique to study materials with unpaired electron. ये हमारा starting point होगा. With unpaired electron. होगा क्या? That unpaired electron, when they are placed in external magnetic field, the electron's magnetic moment aligns either parallel or anti-parallel to the magnetic field, and that alignment leads to this energy difference. This essentially is an example of Zeeman effect, and that Zeeman effect leads to this energy difference of G mu BB. So when microwave radiation of frequency nu is applied, resonance absorption occurs, and if this frequency matches with G mu BB, then I find this absorption spectrum. So by अब हम क्या करेंगे, हम न्यू सेम रखेंगे, we will keep the new fixed, but हम B को vary करेंगे. So by varying B but keeping new constant, this should be corrected. By varying magnetic field but keeping new constant, EPR spectrum is obtained. तो magnetic field को vary करेंगे but frequency को हम same रखेंगे, and we will find a EPR spectrum. And that EPR spectrum, of course, will have a lot of applications which we are going to discuss in the end. But meanwhile, what is the difference between NMR and EPR? Both are magnetic resonance, but they differ in focus and type of radiation. NMR देखो क्या है? NMR में हम टारगेट करते हैं न्यूक्लियाई को, और हम ऐसे न्यूक्लियाई को टारगेट करते हैं जिसका जो स्पिन है वो नॉन जीरो है. EPR में हम किसको टारगेट करते हैं? हम एटम्स को टारगेट करते हैं. कौन से एटम्स को? जिनके पास अनपेयर्ड इलेक्ट्रॉन है. NMR occurs at lower magnetic field and frequency which is often less, about 400 megahertz, but EPR requires higher magnetic field and frequency which is more, such as 9 gigahertz. NMR is less sensitive compared to EPR. EPR is much more sensitive to local environment. So these are some of the basic differences between nuclear magnetic resonance and EPR. And what are the applications of EPR? We use it in material sciences to study particularly free radicals, reaction mechanisms, to find defects in crystalline solids, to probe metal ions, particularly with unpaired electrons, study of certain proteins and enzymes with paramagnetic center, studies of radiation damage in materials and biological tissues. All of these are possible applications of electron paramagnetic resonance or electron spin resonance. EPR और ESR, they both are same thing. तो ये सारी चीजें हम लिखेंगे, हमारा आंसर कंप्लीट होगा. I do not like such type of questions because यहाँ पे मैथ्स कम है, लिखना ज्यादा है. ये जो फोर्थ का ए है, ये एग्जैक्ट सेम क्वेश्चन जो है पेपर 1 में था, अभी मैंने परसों डिस्कस किया था, डे बिफोर यस्टरडे. ये एग्जैक्ट सेम क्वेश्चन पेपर 1 में है. आपको फर्मी एनर्जी कैलकुलेट करना है. देयर इट वाज आस्क्ड इन स्टैटिस्टिकल फिजिक्स. सो व्हाट इज यहाँ पे एनर्जी डेंसिटी, फर्मी एनर्जी क्या होता है? फर्मी एनर्जी इज दिस मिनिमम एनर्जी ऑफ हाईएस्ट ऑक्यूपाइड स्टेट एट एब्सोल्यूट जीरो टेम्परेचर. फर्मी एनर्जी का वैल्यू h क्रॉस स्क्वायर बाई 2m 3 पाई स्क्वायर n 2/3. n जो है वो आपका नंबर डेंसिटी है. व्हाट इज n? रो इंटू Na बाई A. Na is Avogadro's number, rho is density, A is atomic number. Put all of that, you get your n. n in case of sodium is 2.54 10 to the power 28 electrons per meter cube. सब कुछ वैल्यू पुट करो, फर्मी एनर्जी इलेक्ट्रॉन वोल्ट में आ जाएगा 3.15 इलेक्ट्रॉन वोल्ट. हमने सेम कैलकुलेशन अभी पेपर 1 में भी किया था. और अगला क्वेश्चन भी देखो, बड़ा सिंपल है. ड्रॉ द एनर्जी लेवल डायग्राम एंड मैथमेटिकल एक्सप्रेशन फॉर द फॉलोइंग. En of an electron confined in one dimensional box, linear harmonic oscillator. Make a qualitative comparison of the two above cases. तो हम सबने सब कुछ कर दिया है. वेव फंक्शन हमको पता है. इन 1D बॉक्स एनर्जी हमको पता है n स्क्वायर पाई स्क्वायर h क्रॉस स्क्वायर 2ml स्क्वायर. इसको हम मान लेते हैं एप्सिलन. सो दिस बिकम्स n स्क्वायर एप्सिलन. ठीक है, इसको n स्क्वायर एप्सिलन हम लिख देते हैं. तो हमने वेव फंक्शन को भी प्लॉट कर दिया है यहाँ पे. दिस इज द प्लॉट ऑफ वेव फंक्शन फॉर n इज इक्वल टू 1, n इज इक्वल टू 2, n इज इक्वल टू 3. n इज इक्वल टू 1 के लिए एनर्जी क्या होगा? एप्सिलन होगा. इट इज नॉट जीरो, मिनिमम एनर्जी इज नॉट जीरो. n is equal to 2, it is 4e. n is equal to 3, it is equal to 9e. This is my plot En versus n, that how with n energy is varying. लीनियर हार्मोनिक ऑसिलेटर का वेव फंक्शन ये लिखने की जरूरत नहीं थी, ये लिखने की कोई जरूरत नहीं है आपको एग्जाम में, बट जस्ट बिकॉज आई रोट अर्लियर आई हैव मेंशन्ड इट हियर आल्सो. दिस इज लीनियर हार्मोनिक ऑसिलेटर, बट ये लिखने की जरूरत है. फॉर लीनियर हार्मोनिक ऑसिलेटर En इज n प्लस हाफ h क्रॉस ओमेगा. लीनियर हार्मोनिक ऑसिलेटर के केस में साई 0x साई 1x, बट ये आपको बनाना है. n is equal to 1, energy is h cross omega by 2. n is equal to 2, energy is 3 by 2 h cross omega. n is equal to 3, 5 by 2 h cross omega. ये हमारा प्लॉट है. कंपैरिजन क्या होगा? सबसे सिंपल कंपैरिजन तो हमको यही दिख रहा है कि इन one dimensional infinite square world potential, the energy gap was increasing. It was 1, then 4, then 9, then 16. But यहाँ पे energy gap harmonic oscillator के केस में same spacing है, that is h cross omega. दोनों के केस में ground state non-zero है, that is another comparison. For particle in a box, wave functions are sinusoidal. Harmonic oscillator का wave function जो है वो Gaussian है. तो ये कुछ हम एक comparison कर सकते हैं both cases में. This was again a very simple, very straightforward question. Okay, fourth B, I was not able to do the final calculation. इसीलिए in fact मुझे काफ़ी सारा टाइम भी लगा. मैंने क्लास थोड़ा लेट इसलिए शुरू किया आज, because I was not able to find the exact answer what is asked by UPSC here. देखो क्या क्वेश्चन है? That show that for a diatomic molecule with two nuclei of mass m separated by a distance a, the rotational energy of nuclear motion is lower than the electronic energy by a factor of me by m. m is mass of diatomic molecule, एक nuclei का mass, and me is mass of electron, which tells you that rotational energy is very, very less compared to electronic energy. So I thought of doing this. Rotational energy for diatomic molecule we know h cross square by 2i, j plus 1. J is angular momentum. I क्या है हमारा? mu a square. Mu is reduced mass. अगर homonuclear diatomic atom हो तो reduced mass क्या होगा? m by 2 होगा. तो 2i क्या हो गया मेरा? m a square हो गया. तो E rotational हमको पता है h cross square by m a square, j plus 1. ये हमारा रोटेशनल एनर्जी आ गया हमको. तो यहां तक तो चलो ठीक है. इलेक्ट्रॉनिक एनर्जी में हम एक एजम्पशन लेते हैं. इलेक्ट्रॉनिक एनर्जी जो है, हम बोर्स थ्योरी, हम बेसिकली इलेक्ट्रॉनिक एनर्जी को हम एज्यूम करेंगे दैट इट डिपेंड्स अपॉन प्रिंसिपल क्वांटम नंबर. एंड इफ आई एज्यूम अ हाइड्रोजन लाइक स्ट्रक्चर, हाइड्रोजन एटम लाइक स्ट्रक्चर, देन आई कैन राइट दैट इलेक्ट्रॉनिक एनर्जी इज माइनस me e to the power 4 z square 8 epsilon naught square h square n square. The main point is that it varies as per n. And if I take the ratio of these two, h cross square by ma square jj plus 1, me e4 z square at epsilon naught square h cross square n square, and I try to simplify this. So this is where I was stuck. Do all of this. I find this 8 epsilon naught square h cross 4 me a square e4 jj plus 1 n square z square. अब हम आगे कैसे बढ़ेंगे मैंने इसके बाद किया नहीं है, तो दिस इज नॉट अ कंप्लीट सोल्यूशन. वन थिंग विच आई थॉट ऑफ डूइंग हियर इज दैट हम बोर रेडियस फिट करते हैं. दैट जो बोर रेडियस का फॉर्मूला है हम उसको यूज करते हैं. दैट ए नॉट इज इक्वल टू एम ई स्क्वायर डिवाइडेड बाई 4 पाई एप्सिलॉन नॉट एच क्रॉस स्क्वायर. तो हम यहां पे क्या करते हैं, बोर रेडियस को फिट करने की कोशिश करते हैं और देखते हैं हमारा काम बनता है कि नहीं. और हम सिंप्लिसिटी के लिए हम J को 0 मान सकते हैं, दैट इज द मिनिमम एनर्जी स्टेट. हम Z को 1 रहने देते हैं, या Z को हम 1 मान सकते हैं हाइड्रोजन एटम के लिए, एंड N को भी हम मान लेते हैं 1 मान लेते हैं मिनिमम एनर्जी स्टेट के लिए. तो ये तीनों चीजें मिलके 1 हो जानी चाहिए. फिर दिस बिकम्स 1, एंड देन हम इसको कंपेयर करते हैं ए नॉट के रेस्पेक्ट में, बोर रेडियस के रेस्पेक्ट में, एंड कुछ हमारा ऐसे आ जाना चाहिए एम ई बाई एम ए नॉट बाई ए स्क्वायर, कुछ ऐसे होना चाहिए. एंड द सेकेंड assumption again I can make here is a naught is approximately a for such atoms. तो हमारा फाइनल आंसर एम ई बाई एम निकल के आना चाहिए. दिस इज वट आई हैड होप्ड फॉर बट आई वॉज नॉट एबल टू डू दैट. मे बी यू कैन ट्राई दिस. This is, I think, how we can approach this question, that I can assume Z is equal to 0, Z is equal to 1, N is equal to 1, so that all of this term becomes 1. And then I try to solve this question and try to find ME by M. But I was not able to do that. I will repeat this. So maybe you can try this at home. This is very easy. LS coupling, JJ coupling. Both LS coupling and JJ coupling are schemes to describe interaction of angular momentum in multi-electron system. एक इलेक्ट्रॉन का खुद का एंगुलर मोमेंटम और स्पिन एंगुलर मोमेंटम है, दूसरे इलेक्ट्रॉन का ऐसे बहुत सारे इलेक्ट्रॉन है जिनका एंगुलर मोमेंटम है और स्पिन एंगुलर मोमेंटम है. तो LS coupling क्या होगा? LS coupling is that spin-spin interaction of different electrons occur and then spin-orbit interaction occur. So spin interaction of electron leading to S, sigma Si, Li leading to L, and then this L and this S interacts together leading to final J. So this is called LS coupling. This is what happens in lighter atoms where electrons are closer to each other. And in this interaction, the electrostatic interaction between electron and spin-spin interaction are dominant. Spin-orbit interaction is not dominant. दूसरे केस में क्या है? For every electron, first spin orbit interaction occurs for individual electron leading to J, and all of those J's now combine together. L1 plus S1 J1, L2 plus S2 J2, L3 plus S3 J3, and all of those J's combine together to form the final angular momentum J. So here first individual electrons L and S combine, and then the J of all of those electrons are combined, and JJ coupling occurs in heavier atoms. Spin orbit interaction is dominant in this particular case. तो ये हमारा first part है. Second part में क्या है? Second part of the question is that what are the possible orientation of J for J is equal to 3 by 2 and J is equal to 1 by 2 states that correspond to L is equal to 1. तो ये बड़ा आंसर है. अगेन ये भी बहुत सिंपल है. अगर J is equal to 3 by 2 हो तो Mj हमको पता है. Mj will take 2J plus 1 values, 2 into 3 by 2 plus 1, 4 values. What are those 4 values? Minus 3 by 2, minus 1 by 2, plus 1 by 2, plus 3 by 2, 2 into J plus 1 orientation. And if J is 1 by 2, then Mj is minus 1 by 2 plus 1 by 2, total 2 orientation, 2 into 1 by 2 plus 1. And L आपका दे रखा है that L is equal to 1, S is equal to 1 by 2. So J can take all the values from L minus S and L plus S. So if L is 1, then it can take 1 plus 1 by 2, 3 by 2, but it can also take the value of 1 by 2. And we already have calculated that there are 4 possible orientations for j is equal to 3 by 2 and 2 possible orientation for j is equal to 1 by 2. So if L is equal to 1, j is equal to 3 by 2, 4 such orientations. If L is equal to 1, j is equal to 1 by 2, 2 such orientations. This is the final answer. And that is how we conclude the discussion of the first part. Easy. First part was easy this year, except 1 or 2 questions. More or less, this was very much a doable paper. I'm going to take a break here, and after that I will resume with the second part, section B of the paper.
Does the vast syllabus of general studies for the UPSC prelims overwhelm you to initiate your preparation for the civil services examination? Is your apprehension and self-doubt coming in the way of your success in joining the civil services? Comprehend your preparation for UPSC Prelims 2025 with the fast-track course targeting general studies with innovative curriculum, revision and mentorship. Starting from 19th November at 1 p.m, the course offers coverage of UPSC GS Prelims subjects, dedicated mentorship support and guidance for performance maximization, access to PT 365 classes for current affairs preparation, sectional mini tests for regular assessment and performance, personalized student portal to access study material, access to live and online classes. Enroll today and make prelims your stepping stone to proceed to the UPSC mains.
Section B is traditionally considered more difficult in paper 2 than section A. By the way, that is also true in case of paper 1 because of electricity and magnetism part, but here it is all parts. I often have felt that students do not do the same level of preparation for nuclear and particle physics, and they ignore solid state physics, devices and electronics part. So that is why whenever paper 2 mein jo section B hai, if it has easy question, then I will consider that to overall a good paper. And this was the case this year, that you had many questions which were very much solvable questions. The very first question is compare nuclear density of hydrogen with its atomic density. Assume the atom to have the radius of its first Bohr orbit. What inference can one get from the above comparison? तो ये तो बहुत ही सिंपल क्वेश्चन है. वी यूज सिंपल मैथमेटिक्स. डेंसिटी क्या होता है? मास बाई वॉल्यूम. न्यूक्लियस में प्रोटॉन है. न्यूक्लियस का जो रेडियस है वो फेम्टोमीटर में है. हाइड्रोजन का जो रेडियस होता है वो अबाउट 1.2 फेम्टोमीटर है. पुट द वैल्यू ऑफ फेम्टोमीटर. न्यूक्लियस का डेंसिटी जो आया आपका, दैट इज इन द रेंज ऑफ 10 to the power 17 kg per meter cube. Same thing we do in atom. In case of hydrogen, you have 1 proton, 1 electron. But electron का mass जो है proton के सामने negligible है, so I can neglect that. First Bohr orbit में atomic radius is 0.529 angstrom. तो हमारा जो रो atom है वो आ गया. I put the mass of proton, volume of atom. The density of atom is about 10 to the power 3 kg per meter cube. ये 10 to the power 3 है and ऊपर 10 to the power 17 है. Such a huge difference. A difference of 10 to the power 14. What does that tell you? It tells you that most of the atom is empty space, but at the center you have this very dense object which we call nucleus. This indicates that most of the volume of an atom is empty space around a very dense nucleus. This also explains why nuclear energy releases such a large amount of energy, because most of the mass of atom is concentrated inside nucleus in a very small space. And if you use energy is equal to mass mc squared, Einstein's formula, then you get the idea that why nuclear energy is so high. And this also implies that there is a very strong force that overcomes electromagnetic repulsion. That in such a small range you have such powerful density, right? And that tells you about a very powerful force which helps in overcoming electromagnetic repulsion. So we can infer lot of information from this huge difference in density of atom and density of nucleus. Next question is again very simple. Spacing between successive 100 planes that is given. X-rays incident on the surface of crystal are found to give rise to second order n is equal to 2 Bragg reflection at glancing angle 10 degree. Theta हमारा 10 degree है. Calculate the wavelength of X-ray radiation. तो इससे easy question तो कुछ हो ही नहीं सकता. At max हम इसको थोड़ा और ठीक करना था, हम एक यहाँ पे डायग्राम बना देते. We could have used a diagram here. We could have used a diagram and this here is angle theta. जो reflection angle है हमारा वो theta है. तो हम ये diagram बना के हम कर सकते थे. So theta is equal to 10 degree. D is given, n 2 दे रखा है, second order reflection है. Lambda is 2 d sin theta by 2 d sin theta. D is given, theta is given. Answer जो आपका lambda आ गया 0.2445 angstrom, which by the way is X-ray. इतना जो कम wavelength है that belongs to X-ray. तो वन ऑफ द सिंपलेस्ट क्वेश्चन अगेन पेपर का है, सीधे फॉर्मूला आपको यूज करना है. थर्ड क्वेश्चन, फॉर द ग्राउंड स्टेट ऑफ ड्यूटेरॉन प्रूव दैट द रेडियस ऑफ न्यूक्लियन इज प्रोटॉन और न्यूट्रॉन इज इन द ऑर्डर ऑफ 2.15 10 to the power minus 13 सेंटीमीटर. थोड़ा बहुत आपको वेव फंक्शन सॉल्व नहीं करना है, थोड़ा बहुत आपने प्रेजेंट किया पहले तो कि ड्यूटेरॉन प्रॉब्लम को हम मान के चलते हैं दैट दिस इज एन एग्जांपल ऑफ डीप स्क्वायर वेल पोटेंशियल, राइट, फाइनाइट स्क्वायर वेल पोटेंशियल, सॉरी, फाइनाइट स्क्वायर वेल पोटेंशियल. वी एज्यूम ड्यूटेरॉन का जो एनर्जी है बाइंडिंग एनर्जी है बी है. वी नो द वैल्यू ऑफ बाइंडिंग एनर्जी 2.225 MeV. आर जो है हमारा रेडियस है. डू ऑल ऑफ दैट, do simple calculation and we find that radius is 1 by K2, which comes out to be h cross by 2 MB. B is binding energy, I know B 2.2 MeV. M is reduced mass here. Deuteron is 1 proton 1 neutron system, तो reduced mass क्या हो जाएगा, half of proton हो जाएगा MP Mn, MP plus Mn. But remember MP and Mn are almost same, so reduced mass is MP by 2. सब कुछ पुट करके देखो, आपका जो रेडियस आया ड्यूटेरॉन का दैट केम आउट टू बी 4.3 मल्टीप्लाइड बाई 10 to the power minus 13 सेंटीमीटर. तो यह आया 4.3 फेम्टोमीटर इन सेंटीमीटर 4.10 to the power minus 13. बट दिस इज द रेडियस ऑफ ड्यूटेरॉन. हमको क्या करना है, हमको निकालना है रेडियस ऑफ न्यूक्लियन. तो हम ये मान ले अगर दैट जो न्यूक्लियस सेट इज कंप्लीटली ऑक्यूपाइड बाई 1 प्रोटॉन एंड 1 न्यूट्रॉन, तो न्यूक्लियन का रेडियस क्या होगा, इसी का तो हाफ होगा. देखो हम क्या बोल रहे हैं यहाँ पे, हमारा पूरा लॉजिक क्या है यहाँ पे. द लॉजिक इज दैट आई हैव अ न्यूक्लियस विच हैज 1 प्रोटॉन एंड 1 न्यूट्रॉन, समथिंग लाइक दिस, एंड आई हैव कैलकुलेटेड दिस डायमीटर. डायमीटर इज 2 times this, एंड आई नीड टू कैलकुलेट दिस डायमीटर. तो हम क्या करेंगे, इसको हाफ करेंगे और रेडियस के लिए हम 4 और हाफ करेंगे. तो हमारा जो ड्यूटेरॉन का रेडियस है उसको हमको हाफ करना पड़ेगा. हम ये एज्यूम करेंगे, हम लिखेंगे, वी आर गोइंग टू राइट दिस दैट इफ वी एज्यूम nucleus to be occupied by 1 proton and 1 neutron and assume that 2 nuclei to have similar radii, then what will be the radius of nucleon? 4.3 by 2, which is 2.15 10 to the power minus 15 femtometer, and that femtometer is nothing but 2.15 10 to the power minus 13 सेंटीमीटर. तो लास्ट में आपको थोड़ा बहुत एजम्पशन करना पड़ेगा, तब जाके आपका फाइनल आंसर आएगा. नेक्स्ट क्वेश्चन देखो क्या है. What is meant by strength of interaction of elementary particles? Classify the different forces on the basis of this strength of interaction. Strength of interaction का meaning बहुत simple है. It refers to the relative magnitude Interaction of elementary particles refer to the relative magnitude of the forces that act between particles at fundamental level. This is the meaning of the strength of interaction. We know that there are 4 fundamental interactions. The first is strong interaction, जिसका जो relative strength है हम 1 ले ले, इससे हम compare करेंगे बाकी का. This is the strongest, but it is a short range force that binds quarks together. इतना हम अगर लिखेंगे more than enough है. Electromagnetic interaction, इसका जो relative strength है वो about 10 to the power minus 2 है. It is governed by fine structure constant 1 by 137. So it is second strongest interaction and a long range force. This is electromagnetic interaction. Weak interaction का जो relative strength है वो 10 to the power minus 13 है. Extremely short range 10 to the power minus 18 meter. Third strongest force. And gravitational force is the weakest. Relative strength is 10 to the power minus 38. It is a long range force. ये values आपको याद रखने पड़ेंगे. Fundamental interactions सीधे सीधे syllabus में दे रखा है आपका paper 2 में. So you'll need to remember these values of the relative strength. Only then you can answer this question, right? Anyways. The last question is, what does supercritical magnetic field depend on temperature? How does it depend? Then some values are given for a superconducting specimen. The critical magnetic fields are 1.45, 4.5 at 14 Kelvin, 13 Kelvin. Determine the superconducting transition temperature and the critical field at 0 Kelvin. तो ये तो बहुत ही simple है. This is the equation. Hc at temperature T is Hc at 0, 1 minus T by Tc whole square. This is the value which we get. This is Hc 0 at T is equal to 0. And this is plot of T by Tc. So T by Tc when it is 1, which means when T is equal to Tc, I have this particular value. So HCT is critical magnetic field at temperature T and Tc is superconducting transition temperature. हमारे पास value दे रखा है, Hc14 का value दे रखा है 1.45, 10 to the power 15 दे रखा है, 10 to the power 5 है. This is not 15. This is 10 to the power 5. There is a mistake here. This is 10 to the power 5. 14 by Tc whole square. And at 13, T is equal to 13. The value is 4.2 into 10 to the power 5, Hc0, 1 minus 13 by Tc square. I have these two equations. I have two unknown, Hc0 and Tc. हो गया हमारा काम. तो 2 को 1 से डिवाइड करो. 4.2 by 1.45 is 1 minus 13 by Tc square, 1 minus 14 by Tc square. ये रेशियो is 2.897. ये इधर जाके मल्टीप्लाई होगा. सॉल्व फॉर Tc. Tc comes out to be square root of 210 Kelvin, 14.5 Kelvin. तो जो मेरा क्रिटिकल टेम्परेचर है वो 14.5 Kelvin है. एंड Hc0 at T is equal to 0 Kelvin क्या हो जाएगा? आप ये Tc का वैल्यू रख दो. Hc0 comes out to be 2.14 into 10 to the power 6 एम्पियर पर मीटर. ये हमारा आंसर आ गया. तो ये सिंपल सा फॉर्मूला आपको याद होना चाहिए. ये फॉर्मूला अगर याद है तो आपका आंसर हो जाएगा. Does the nucleus possess magnetic moment? Justify your answer. Define nuclear magneton, Bohr magneton, calculate their values. तो ये बहुत ही सिंपल है. अगेन ये भी क्वेश्चन. Yes, most nuclei does possess magnetic moment. Why? This is intrinsic angular momentum called spin. Protons and neutrons have this intrinsic angular momentum called spin. And if the number is odd nuclei, so the individual magnetic moments of protons and neutrons combine to give the nucleus an overall magnetic moment. Even nuclei में that will be 0. But जो odd nuclei हैं, there will be magnetic moment. And जो nuclear magneton है, that is a natural unit of magnetic moment of proton. That is defined as EH cross by 2 MP. Calculate this value. 5.05 multiplied by 10 to the power minus 27 joule per Tesla. And Bohr magneton is natural unit of magnetic moment of electron. That is defined as EH cross by 2 ME. यहाँ से आपका वैल्यू आ गया 9.27 10⁻⁻24 जूल पर टेस्ला। एंड हम एक और लाइन लिख सकते हैं यहाँ पे, जो म्यू एन है देखो बहुत स्मॉल है म्यू बी से, तो मैग्नेटिक मोमेंट ऑफ न्यूक्लियस इज मच स्मॉलर देन इलेक्ट्रॉन, हेंस NMR रिक्वायर्स स्ट्रॉन्गर फील्ड देन EPR। अगला क्वेश्चन क्या है, आपको सेमी इंपेरिकल मास फॉर्मूला लिखना है फर्स्ट पार्ट में, एंड देन फॉर एटॉमिक नंबर Z ऑफ मोस्ट स्टेबल न्यूक्लियाई फॉर गिवन मास नंबर A, आपको इस फॉर्मूला को यूज करके निकालना है, वेर A3 एंड A4 आर गिवन। तो ये भी बहुत ही सिंपल क्वेश्चन है। सेमी इंपेरिकल मास फॉर्मूला इज E1A1A minus A2A to the power 2/3, A3ZZ minus 1A1/3, A4A minus 2Z square A plus minus delta AZ और 0 भी है। तो ये EAZ is binding energy, A1, A2, A3, A4 are constants determined empirically. This represents volume term, this represents surface terms, this represents Coulomb repulsion, this represents asymmetric energy, and finally this represents pairing energy. That pairing energy can be positive, negative or 0 depending upon what type of pairing it is. और अब हमको क्या करना है, हमको A दे रखा है, हमको Z, कौन से Z पे सबसे मोस्ट स्टेबल होगा, डेली दे रखा है, डेली को डेल Z से आप डिफरेंशिएट करो, तो डेल Z से अगर आप डिफरेंशिएट करोगे तो ये टर्म और ये टर्म तो 0 है पहले ही, इसको तो आप आराम, ये कांस्टेंट है। इफ A is constant then remove this part. I only need to worry about third part and fourth part. This is what I do. Differentiate the third part, A3 2Z minus 1 A 1/3, 4A 4A minus 2Z by A. आप रीअरेंज करो सब कुछ और आपका ये आंसर निकल के आएगा, that Z is equal to 4A4 A 1/3 plus A3, 2A3 plus A24 A raised to power minus 2/3. A4 का वैल्यू हम दे रखा है एग्जाम क्वेश्चन में, A3 का वैल्यू दे रखा है, put all of that, this is the equation you are going to get. So if some A is given, then you can determine that what will be the most stable Z for that particular A. तो हम ये आराम से निकाल सकते हैं। आइसोबार में सबसे स्टेबल आइसोबार कौन सा होगा, आप कुछ करके देख लो। A आप यहाँ पे 200 डाल के देख लेना, A आप यहाँ पे कुछ 56 डाल के देख लेना, Z जो है 26 के आसपास आ जाएगा, आयरन निकल के आ जाएगा। So you can do this. So for specific A we can calculate Z. ये हमारा एक सिंपल सा आंसर आ गया। नेक्स्ट क्वेश्चन इज Q वैल्यू। Q वैल्यू इज नथिंग बट M1 माइनस M2 C स्क्वायर। आपको M1 का प्रिसाइज वैल्यू लेना पड़ेगा, M2 का प्रिसाइज वैल्यू लेना पड़ेगा, जो कि क्वेश्चन में दे रखा है। डेल्टा M is 0.006133. 1 AMU converts, produces energy of 931.5 MeV. Here it is 0.00613. Multiply this, the Q value is 5.711 MeV. This should be the answer. बस ये 5 नंबर का क्वेश्चन है, एक लाइन का फॉर्मूला है MC square. You need to just calculate that M here. The next question is about all the conservation laws. And then using these conservation laws, you have to determine that if these two reactions are possible or not. Conservation of energy, momentum, angular momentum. Take these three interactions, strong, weak, electromagnetic. So, conservation of energy, momentum, angular momentum, charge, lepton number, baryon number. These conservation laws are valid for all the fundamental interactions. Strong के लिए, weak के लिए, electromagnetic के लिए. हमने टेबल बना के लिखा है that energy, momentum, angular momentum, charge, lepton number, baryon number. ये सब के लिए कंजर्व रहेगा. अब हम बाकी का देख लेते हैं conservation law. If it is isospin का magnitude, total magnitude, then it will be conserved in strong but not in weak and electromagnetic interaction. If it is component of isospin, Iz, it is conserved in strong, not in weak, but also conserved in electromagnetic interaction. Same is true for strangeness, same is true for parity. Parity particularly is very important. It is only violated in weak interaction. Charge conjugation only violated in weak interaction. But time reversal and charge P, parity and time reversal together, they are conserved in all these fundamental interactions. So in few fundamental interactions, in fact weak interaction, strangeness, parity, charge conjugation and isospin component is not conserved. ये आपको isospin is also not conserved in isospin component is conserved in electromagnetic interaction, but I is not conserved in electromagnetic interaction. Total value of I is not conserved in electromagnetic interaction. तो ये आपको टेबल बना के लिखना पड़ेगा. जब आप पूरा टेबल लिखोगे तभी आपको मार्क्स मिलेगा, राइट? तो ये खाली कंजर्वेशन लॉ का नाम नहीं लिखना है. You should also mention that for which fundamental interactions, which of the conservation laws will be applicable. अब ये दो जो रिएक्शन दे रखा है तो बहुत ही सिंपल है. पाई प्लस N0 K0 K प्लस. टोटल चार्ज यहाँ पे क्या है? +1 है, 0 है. सो टोटल चार्ज हियर इज +1, टोटल चार्ज हियर इज +1. तो देखो चार्ज तो कंजर्व्ड है, राइट? बट बेरियन नंबर देखो, पाई मेजॉन का बेरियन नंबर इज 0, न्यूट्रॉन का बेरियन नंबर इज +1. बट K इज नॉट a baryon number for K is 0. So baryon number is being violated here. This side I have baryon number +1, this side I have 0. Baryon number is not conserved. This reaction is not at all possible. And अगला तो और सिंपल है. न्यूट्रिनो, प्रोटॉन, न्यूट्रॉन, इलेक्ट्रॉन. यहाँ पे चार्ज क्या है? 0 + 1. टोटल चार्ज हियर इज +1. यहाँ पे टोटल चार्ज क्या है? 0 - 1. तो यहाँ पे चार्ज ही कंजर्व नहीं है. तो आगे हमको देखने की जरूरत ही नहीं है. चार्ज इज नॉट कंजर्व्ड, रिएक्शन इज नॉट पॉसिबल. सिंपल. चार्ज कंजर्वेशन इज वायलेटेड, रिएक्शन इज नॉट पॉसिबल. तो ये बहुत ही सिंपल दो एग्जांपल यूपीएससी ने पूछा था. दैट पॉसिबल है नहीं. ये भी नहीं पूछा था कि कौन से, पहले तो ये भी पूछती यूपीएससी कि कौन से पॉसिबल हैं, और अगर पॉसिबल हैं तो विच फंडामेंटल इंटरैक्शन इज इसेंशियली कॉजिंग दैट पर्टिकुलर रिएक्शन, राइट? तो वहां पे थोड़ा फिर भी दिमाग लगाना पड़ेगा. ये तो बहुत ही सिंपल स्ट्रेट फॉरवर्ड क्वेश्चन है. What is the origin of paramagnetism? Discuss the temperature dependence of paramagnetic susceptibility. So this is also a standard question. Paramagnetism arises due to presence of unpaired electron. ये important keyword है. Unpaired electron in atoms or ions of a material. Magnetic moment is not cancelled. अगर unpaired है तो magnetic moment cancelled नहीं होगा. What does that mean? That when I apply an external magnetic field, then the magnetic moment of unpaired electrons align in that particular direction. If there is no external magnetic field, this is random alignment. I do not have to, but the moment I have some external magnetic field, there is an alignment. And that results into a net magnetic moment in the direction of the field, and we call this behavior as paramagnetism. The second part of the question is that what is its dependence upon temperature? It is inversely proportional to that. That is called Curie's law. The C is called Curie's constant, and इसको समझना बड़ा आसान है that why it is inversely proportional, because at high temperature the thermal energy disrupts the alignment of magnetic moment. High temperature means more energy, and the thermal energy disrupts the alignment of electrons, and that reduces the magnetic moment inversely to the temperature. We often use C by T minus theta here also. Theta plays a very important role. But ठीक है, इतना भी लिख दोगे तो more है. But ये लिखना पड़ेगा आपको that why there is an inverse proportionality. This inverse proportionality is simply because of thermal energy causing disruption of the alignment of magnetic moment. And then in the next question, calculate the diamagnetic susceptibility of atomic hydrogen. One hydrogen atom. In the ground state at simple temperature and pressure, assume the mean square distance is r square 3a0 square, a0 is Bohr radius. तो ये तो देखो बिल्कुल ही फॉर्मूला पता होना चाहिए तभी आप कर पाओगे. अगर फॉर्मूला पता है तभी ये कर पाओगे, जो diamagnetic susceptibility है mu naught z n e square r naught square by 6m. m is mass of electron, z is atomic number, n is number of atoms per unit volume. बट यहाँ पे चूंकि एक एटम की बात कर रहे हैं तो हम n को एक ले लेंगे हम, n will be 1 here. So put all of that. r naught square दे रखा है 3a naught square. What is a naught? Bohr's radius 0.529 10 to the power minus 10. Put all of that, magnetic susceptibility comes out to be 4.946 10 to the power minus 35 meter cube per mole. But ये देखो बहुत ही कम magnetic susceptibility है. Actual magnetic susceptibility which we do find is in the range of 10 to the power 6 minus 6. And that makes a lot of sense because generally the number of atoms per meter cube, that will about be 10 to the power 29 per meter cube. So for 1 meter cube, when we calculate this magnetic susceptibility, then I need to multiply here with 10 to the power 29, and that will lead to 10 to the power minus 6, and that we observe that जो measured magnetic susceptibility है, that is about 10 to the power minus 6. तो ये फॉर्मूला अगर याद नहीं है तो आंसर नहीं हो पाएगा. What is the concept of effective mass of electron? Then the second part is the near valence band energy is given. Electron is removed from the orbital. Find the sign and magnitude of effective mass of the hole. ये 20 नंबर का क्वेश्चन, इतना सिंपल क्वेश्चन है जो यूपीएससी ने 20 मार्क्स का पूछा है. सॉलिड स्टेट फिजिक्स में इफेक्टिव मास का देखो मीनिंग क्या है, दैट हाउ इलेक्ट्रॉन्स रिस्पॉन्ड टू एक्सटर्नल फोर्स. And electrons are affected by the periodic potential of lattice. Remember solid state physics mein, when we look at the potential energy, then it is not free electron. That free electron approximation is modified, and we follow this periodic potential. That periodic potential leads to these bands which you study in solid state physics. But the concept of effective mass here is that how it responds to external force within a lattice, taking into the account of influence of periodic potential. And this concept of effective mass essentially determines electrical and thermal properties of solids, particularly semiconductors. And effective mass is nothing but H star d2e by dk2. ये दिखाया जा सकता है that effective mass will be d2a by dk2. इस क्वेश्चन में आप चाहे तो आप डिराइव कर सकते थे. यहाँ पे E के दे रखा है, d2e by dk2 निकालो, m स्टार आपका आ गया. ये माइनस इसलिए होगा, जब इलेक्ट्रॉन को हम रिमूव करेंगे, इलेक्ट्रॉन इज रिप्रेजेंटेड विथ माइनस साइन, बट व्हेन इलेक्ट्रॉन इज रिमूव्ड it leaves behind a hole which has the opposite sign of effective mass. So same mass but opposite sign, effective mass is positive. ये हमारा आंसर आएगा 5.55 10 to the power minus 29 gram. This is a very very simple 20 marks question. However, I will repeat that one part because I did this in hurry. Just before the class I was doing all of that. I did this in hurry. So ideally you should also derive that formula of effective mass. RC coupled transistor amplifier has mid frequency gain AVM 100. Value of lower and upper cutoff is F1 20 Hz, F2 50 kilohertz. Find the frequency at which the gain is reduced to 80. AVM is 100, gain is reduced to 80. अब इसका अगर आपको फॉर्मूला पता है तब भी आप आंसर कर पाओगे. फॉर्मूला अगर नहीं पता है तो आप बिल्कुल आंसर नहीं कर पाओगे. फॉर्मूला इज दैट AF इज AVM 1 plus F1 by F square, F by F2 square. AF is voltage gain, AVM is mid frequency जो दे रखा है क्वेश्चन में, and F1 F2 आर कट ऑफ फ्रीक्वेंसी जो आपके क्वेश्चन में दे रखा है. तो सब कुछ पुट करो. प्रॉब्लम में क्या दे रखा है 80 100, F1 F और F by F2 भी दे रखा है. रिमेंबर F1 इज 20, so 20 400 by F square, F2 is 550 kilohertz, so this becomes 25 into 10 to the power 6 square, so 500 into 10 to the power 3 square, that is the answer. So I have now a quadratic equation. Look, this is a quadratic equation. Solve this quadratic equation, you get this two values of frequency. One is 26.67 Hz 37.5 kilohertz, and you have your answer. तो यहाँ पे आपको एक quadratic equation solve करना पड़ेगा, तभी आप यहाँ पे कर पाओगे, right? तो anyways, this is the answer which you are going to get.
A stronghold over current affairs is your way to succeed in the UPSC Civil Services examination. Brace yourself and get detailed coverage of relevant news both nationally and internationally. With the monthly current affairs revision program starting from 26th October at 5 p.m. Enroll today and elevate your current affairs knowledge with comprehensive coverage of current affairs compiled through relevant sources such as the Hindu Indian Express, Economic Times, PIB Yojana, and others. Expert support and personalized mentoring. Comprehensive assessment through MCQs and mains-oriented questions.
The last question, what is nuclear resonance absorption of gamma rays? Describe the working and application of Mossbauer spectrometer. तो ये भी बहुत ही simple question है. Nuclear energy में भी differences हैं. When a nucleus absorbs a gamma ray of suitable frequency, of specific energy, that matches the energy difference between the two nuclear energy, nuclear resonance absorption occurs. The same way, the resonance absorption occurs in case of electrons. You have the same similar type of, so in electrons, it leads to atomic transition, here it leads to nuclear transition. But when nucleus comes back to its natural state, it releases frequencies, and that is what is used in Mossbauer spectroscopy. So what is Mossbauer spectrometer? This utilizes the phenomena of nuclear resonance absorption to study the properties of materials based on Mossbauer effect, which involves the recoilless emission and absorption of gamma rays by atomic nuclei. आपको setup बताना है कि setup क्या होगा? Setup will be a source which will be a radioactive isotope such as cobalt-57 or cobalt-60 which emits gamma rays. An absorber जिसको आपको study करना है, a target material basically which can be some material, some solid. It includes Doppler shift also. Now this is very interesting that हम क्या करेंगे, source या absorber को move करेंगे. उससे क्या होगा, Doppler shift होगा, the frequency will change, and that frequency then should match the frequency of the nuclear transition. And then there will be a detector which is going to detect the gamma rays that passes through the absorber, and based on the Doppler velocity, I do a spectrum, and this is a simple like representation of that. I have a radioactive source which leads to gamma emission, which leads to resonant absorption. And by doing this Mossbauer spectroscopy, we can use it for multiple things: electronic, magnetic, other properties of materials, hyperfine structure in nuclear physics, to study chemical bonding, to investigate magnetic properties. All of these are applications of Mossbauer spectroscopy. The next question is, how is digital system different from analog? What are principles, reasons for the widespread use of digital electronics? So, ये तो बहुत ही simple है. Analog is continuous signal, a continuous fluctuation of voltage or current. Discrete signal representing binary, high voltage 1, low voltage 0. Much more prone to noise and signal degradation, much more precise. Information is presented by variations in amplitude, frequency, phase using modulation. Information is encoded in binary system. That is the fundamental difference. And why digital? Again, I have done all of that in very hurry, a lot of hurry. More robust against noise, better error correction, easy storage and processing. Remember, जो हमारे computers हैं, they are also using binary system. So signal processing becomes easier if I am also using binary signal. इसको reproduce करना आसान है, program करना आसान है, ज़्यादा flexible है. So all of these are benefits that why digital electronics is so prominent in the world and analog is not. And one more question I have done. I have not done the last question. Compare the working of FET and MOSFET, with the structure IV, curve and transfer characteristic. I will have to look for people who have expertise in this topic, right? Or I'll have to, I'm reading that. So I do not have background in electronics per se. So I'm reading electronics, right? So I have not done this part, but I know digital electronics. Digital electronics तो बहुत आसान है, बहुत ही simple है. 12 नंबर का क्वेश्चन है, give logic diagram, Boolean equation and truth table of AND or NOT gates. Show that NAND NOR gates can be utilized as a universal gate. अब logic diagram तो देखो मैंने नहीं कर रखा है अभी यहाँ पे, but मैंने equation दे रखा है. Again I did that in hurry. AND gate is A dot B. This is the truth table. Output is high when both A and B are high. OR gate is A plus B. Output is high if either of them are high, and if both of them are high, then output is again high. That is OR gate. And NOT gate is this reversal gate. It makes, if A is 0, NOT gate makes it 1. If A is 1, NOT gate makes it 0. And then the question is asking that NAND gate is a universal gate. NAND gate is A dot B bar. This is the truth table of NAND gate. You simply have to demonstrate that using NAND gate, you can find OR gate, you can find AND gate, OR gate, AND gate, and NOT gate. This is what we have done here. Ideally, this should involve a picture. We should keep making a picture here so that I'll get extra marks for that. NOR gate, same thing. This is the NOR gate, A plus B, and this is the truth table of NOR gate. This is also a universal gate. Right? NOT gate हम बना सकते हैं NOR को यूज करके, OR gate बना सकते हैं NOR को यूज करके, AND gate बना सकते हैं NOR को यूज करके. This demonstrates that even this is a universal gate. That's it. We're done with this discussion. I'm going to make a better. So when this video will be uploaded, I will also ensure that the last sum answer, which I by the way did really fast. So some last answer, I will improve this further with more diagrams, and this updated PDF will be uploaded in the video description. By the way, if anybody has any question regarding physics preparation, you can always send me a mail. Abhishek@visioneyes.in. And all the best, guys, for your preparation.